Hi, I'm John Dealstra with Mohawk College Building Renovation Technician Program. We'll be going through real quick how to mill up a piece of 6/4 pine or any rough sawn lumber into a piece of finished material that you could use for trim, doors, any other material that you need. We're going to start over here on the joiner. This joiner has been set so that the in-feed table and the out-feed table are perfectly parallel, and so that the in-feed table is down 1/8 of an inch from where the cutter head is. We have a 6-inch helical cutter head on this machine. It runs on 110 volt, and we'll just be going through. We're going to start by looking at the piece of lumber. We're going to go from this area here where we've got a high point and a high point on one edge rather than the high point in the center. This piece has very little cupping going on. I've taken a straight edge and checked, and this edge is a little bit lower here and here. We're going to try and even those edges out so that we get a nice flat surface on one edge. So I'm just going to go here. We're going to use all our safety equipment. All our guards are in place and functioning. I checked that before we even start. I'm going to be using a pusher stick to guide the piece through the machine. At this point, I'll be hugging the edge, but this fence really doesn't do much except hold my piece in place. When we tip it up from the face to the edge, like this, we'll be actually using this to make sure it's nice and square. Before we started, I've taken a framing square or any sort of square and checked that these two surfaces are perfectly square from this edge to this edge. All right, let's get going. So as you can see, in 2 passes there, we've gone from a rough surface, such as this, to a smooth surface most of the way through. I'll throw it through one more pass. If you notice here, we've got a bit of checking here. I'm going to actually reverse my feed for this pass and see if I can clear that up. The grain in this piece is a little bit hard to follow since it's got a couple knots. So we'll try feeding it the other way, see if we get a little less chipping. These helical heads are great for that. They do a lot less chipping than the standard straight knives, but you still get a little bit every now and then that'll need to be sanded out or planed out of there. Now I've got one straight piece here that's completely smooth. It's not finish ready. It'll need to be sanded if we were to take it right off the joiner. Now we'll go from planing one face, or jointing one face, to jointing one edge. This edge will go tight up against the fence, which again is square to the joiner bed. We're going to have to sight down this board and see if it's got a bow going either way. If it does, we have to nick the high points off. If we were to take it and it were to rock like this, we would simply create a boat pattern from going through it several passes. You're never going to get a nice straight edge if you do it like that. We're utilizing the straightness and flatness of the bed of the joiner in this case and getting one nice smooth finished edge that's dead straight and dead square to the first face. We now have one smooth face, one smooth edge. At this point, we're finished with using the joiner. If we were to go and say, take this face off again, we don't know if we're holding the board in there crooked. This is not a long enough face to actually hold square against the fence and trust that we're going through nice and square. At this point, we're going to go from our jointer to our thickness planer over here. We've got one smooth face, one smooth edge. They're square to each other. We trust that our joiner was set up properly. We'll now move on to our 13-inch General International helical head. This is called a lunchbox thickness planer. The reason it's called a lunchbox is it folds up. It's about the size of a lunchbox. All right, what it does is it takes our nice smooth edge face on one side, flip it over, and the head now is on the top, and it will be shaving off the top until we get the board down to the thickness we want. At this point, our board is 1.5 inches thick. I'd like it down to 1.25 inches. I'm going to use it for something that I need 1.25 inches for. So what we'll do is we'll throw it through the thickness planer enough times that we've lost the entire rough surface and we're actually shaving it down to the thickness that we want. So same as before, we've hooked up the vacuum to the joiner and we're going to, or the thickness planer, and we'll actually be going in small increments. This particular lunchbox thickness planer is good for about 1/8 inch per pass. If this were a hardwood, we would definitely not want to take 1/8 inch per pass. It would be too much material and the planer would slow down to the point that we'd be working the motor too hard and possibly trip the breaker. We'll set it based on this little gauge here to take off about 1/16 inch. If that's too much, we'll take off less at a time. That little gauge there is kind of nice. You slide the material underneath where that white arrow is and it'll show you how much the joiner will take off, or the thickness planer will take off approximately. After we take a couple passes with the thickness planer, we can see that our two edges are nice and parallel. We've got nice smooth wood on both sides. It's hard to even tell now which side was jointed and which side was planed. That has to do with how sharp our machinery is here. The helical heads really help with that, especially around the knots and that. But we'll still want to take our tape measure and double check what thickness we're at. At this point, we're down to about 1 3/8 inches. We'll go down to 1.25 inches. We'll take a pass off of both sides so that both of them have come off the thickness planer, are nice and flat and all that. So we'll send one through and then send it through again. At this point, to measure accurately, we're not going to hook the tape on the edge of the board. We're actually going to measure from one of our inch marks, and we see that we're exactly 1/16 inch larger than we need to be. So on this particular planer, one full turn is 1/16 inch. Each joiner and each planer are different. You're going to want to familiarize yourself with how the equipment works before you hop on and start using it. In this case, one turn is 1/16. I'm going to go a little bit less than a turn, just to confirm that I'm near where I need to be. I left the vacuum off in that shot just to show you exactly how much material actually comes out of the thickness planer when you leave it running. All right, we've got our piece milled down on a face, an edge, and a face to 1.25 inches thick by about 4 inches wide. I want a piece that's 1.25 inches thick by 3.5 inches wide. So I'm going to take it from my joiner, my thickness planer, and move on to my table saw, where we can now use the parallel edge and straight edge that we've produced on the joiner, use the parallel fence to the blade on the table saw and cut it down to 3.5 inches thick. This table saw has several safety features. It's got an anti-kickback teeth on it. It's got a guard that drops down into place. and keeps me from putting my hand into the blade. No safety feature though is perfect. It's all about user safety, a user knowing how to use the tool and proceeding through safely. In this case, I know that I'm not going to be able to fit my hand in here safely alongside the guard, so I'm going to use what's called a push stick. This particular table saw, when you buy it, has a built-in push stick along the side of the fence. I prefer this style, which we make in our shop. It allows me to keep some pressure down and in as I move the piece across the table saw. This particular table saw, you adjust the fence not by moving the fence itself, but by adjusting it through this rack and pinion system. This saw will move out to 24 inches thick. In this case, we flip this material support down, so when we're ripping sheet goods down, it's supported along this edge. When we slide the fence back in, we flip that out of the way. And this is where we can make our fine adjustments with this little knob here. Once we've got everything set up where we want it, we lock it into place and double check that it's not going to move. I said I wanted my piece ripped down to 3.5 inches. On this particular saw, it has a guide with a scale on it. As with all our tools, we want to double check that. I didn't trust the scale on our thickness planer. I'm not going to trust the scale on this tool. If this was my tool and I had set it up perfectly, I would trust it. In this case, it's a shop tool where many people use it and nobody necessarily has calibrated it perfectly. So I'm going to bring the fence in to 3.5 inches. Again, my saw is unplugged. I don't want this plugged in at any point while I'm using it until I'm ready to actually use it. So we're going to take the tape measure, we're going to hold one edge against the fence, and we're going to adjust our blade until this edge of the tooth is at 3.5 inches. I don't know if the camera can pick that up. It's at 3.5 inches against the blade. Lock the fence in place, give it a quick shake, check that it's in place properly, move the guard down. Now is where we really have to think about what's going to happen if something were to go wrong with this cut. This cut starts with a knot at this end of the board, which has different spring in it. It might do something funny when I try and push it through. As I'm pushing it through, I would want to stand to the side and make sure that anything behind me is not in danger of getting hurt. If there were people working behind me, I would want to turn the saw so that it's going to kick back in a safe and not harmful direction. So we're going to set up, we've got it set up to 3.5 inches. The table saw is actually going to leave a cut that isn't necessarily safe or nice enough to glue or stain. What I'm going to do is actually move the blade out to 3.5 plus a 1/16, so 3 9/16 of an inch from the blade. What this allows me to do later is take a jack plane or back to the joiner, take one quick pass along that edge and clean it up so that it's almost glue ready. If I have to hit it with some sandpaper or the jack plane to get it perfect, I've got a little bit of room to play. We'll now take our table saw and plug it in. Safety glasses are a must. This is actually the loudest tool we'll be using today. With these helical heads, the joiner and the thickness plane are actually quite quiet. The table saw is quite loud. I would recommend ear protection. In this case, I don't have any on me. We'll go with this one cut. It's actually a quite soft wood, so it's not very loud. What we saw there was the kick tooth actually catch along the back of the saw. The blade doesn't start till here. I knew it was safe to reach around and lift that kick tooth. In general, you're going to want to make sure your tools don't have hang-ups like that. We also have a port on this saw where we could take our hose and hook it up at the back. In general, the table saw doesn't produce as much or as large of chippings as the thickness planer does. But in terms of site cleanliness, if it's easy enough and you've got it sitting around, why not hook up the dust collection? All right, we've now taken a piece of pine, which was 1.5 inches thick to begin with, and we've milled it down to 1.25 inches exactly by 3.5 inches in this direction. However, we actually have it 3 9/16. So if we want to go back to our stationary power tools, our joiner, even our thickness planer could take this edge, which has table saw marks, and even it up so it's a nice smooth cut. I highly recommend getting a nice sharp jack plane, couple passes, and you'll have a great smooth piece of material ready to glue. Thanks for watching. I'm John Dealster with Building Reno.